Since 1999 and has moved to New Zealand in 2001 and is the founding president of the NZPAC and looks after the Python community group on LinkedIn. But the only thing I really know about him is that he works at Catalyst IT. And so it's very easy for me to introduce him that way. But now, without further ado, sorry that we are running a little late, he'll be talking to us about OpenStack and some other things.
Thank you. Right, which means I can basically skip this slide here. So I'll be talking about three big things: Odoo, whatever that is. I'll come to that in a second. Continuous integration and OpenStack. So those are both. All three are topics that you could have multiple talks about.
1 second, mate.
Yep.
Can I just readjust that?
Yep.
Give that a go.
Too loud? Better?
Yep.
Yeah, but this is a fun talk, although I'm German. It's about our experience at Catalyst putting those things together, right? So first of all, I'll say what Odoo is and why it's so big and scary that we need continuous integration. It's not a luxury. And then our setup using OpenStack and how the development workflow on that works, and a few gotchas that we encountered on the way. So in case you want to build this yourself, just some tips. So you may not have heard of Odoo before, but maybe OpenERP. Who hasn't heard of OpenERP? Okay, right. So they've renamed it just recently because one of the reasons they stated, when I say they, it's the company behind Odoo, that it's more than an ERP. But for the purpose of this talk, just imagine it's an ERP and a little bit more. And an ERP is basically software for managing your business. So from the accounting side of things, reporting, down to timesheeting of employees against projects, and so on. So lots of modules, lots of areas, and of course, no one can go in the shop and get the software, do it their way. A reasonably sized company will want the software adjusted, configured, customized, and so on. And that can cost a lot of time and money, and you better hope that they are laughing with you. But areas like Oracle, SAP, but nevertheless, open source business models actually suit that because the software goes out and service and expertise is where you make your money. Configuration, customization, development, maybe hosting, those kind of things. Same with Odoo, which is open source. Just to scare you a little bit, it's large, over 2 million lines of code, not counting comments or blank lines, and almost half of it is XML. Configuring views, storing configuration, these kind of things. And together with JavaScript, that coalition easily governs that software, but still, you've got 680,000 lines of code of Python to play with, and software of that size, certain things are not that attractive anymore. So Catalyst wants to use this software, and needs to customize the software at 200 commits per week. It's also quite active, and we don't really want to touch the software. But as I said, these kinds of software systems are meant to be customized. I'll get to that in a minute. In a second, now. So it's not a framework. If you think of something like a web application framework like Django, you get the bones, you put the flesh on. And you're not customizing an existing application. You get a model base class, and you can define the fields. The user model that ships with Django used to be a problem. That was one of the little pieces of flesh that it shipped with, but it wasn't easy to make changes to that on a global level for the application because it lacked a schema migration, which it now has, I think, since the latest version, last week or something. So if you're changing an existing application, there needs to be easy ways to do so. And another scary part of Odoo is, not that the old name is still in the imports, but the way that it provides the hooks is a bit like monkey patching out of the box. So if you want to add a new field, which we wanted to do here, to an invoice line. So an invoice line has product description, quantity, price per unit, then the rest gets calculated. We wanted to add a work request number, which is something like a ticket number from an issue tracker. You can think of it like that. And rather than subclassing the invoice line, we subclass from the ORM, model-based class, and then have this magical underscore inherit with an identifier that matches an underscore name somewhere in Odoo. And then we add a new field. Now, as Odoo loads up, it injects this into the existing class. So you don't have to tell the rest of the software to now use your class. It just injects it into the existing one, which is scary because in your, when you're debugging, you don't know where things are coming from, especially if model fields aren't attributes themselves, but rather, again, in an underscore columns. Another scary part is the ORM. You ask for all the invoices that were written from the 1st of April, and you get back a sequence of objects. These objects are not invoices. They're browse records. And if you ask for all the employees whose first names start with D, you'll get a list of people, but they're not people. They're browse records, again. And you don't know what attributes they have because they will be magically looked up when you ask for it. So that turns your IDE into a file manager, really. Apart from that, a realistic server setup will consist of a web server in front of the application server and then a database server, hopefully on a separate machine, so that you can tweak it separately, because database servers have different demands. So continuous integration and integration testing, they both use the word integration, but in different ways. Continuous integration, just to quickly rehash this, is when you constantly merge development copies of the source into the main line of development. You do that several times per day and always stay up to date. And of course, this is usually paired with tests to make sure that that doesn't break. And so you're integrating the changes into the main line. Whereas integration testing is when you glue all the components together that make up your software system and test them as a whole. So you're not just running some unit tests and you're happy with that. You'll actually be setting the whole thing up and testing how the components talk to each other and whether they still work. So a cloud service provides service quickly, easily, and they're paid per hour, usually, if you don't have your own cloud, which you can, but apart from OpenStack, which is open source, you'd have to buy quite a bit of hardware. But if we were to build entire servers and throw them away, we can do that per hour. Obviously, it's a perfect fit because when you finish committing at the end of the day, you go to sleep and you don't pay for those servers anymore. Also, when if we set up entire servers, we can do a few things that we can't do in a virtual environment, like performance testing, load testing, scalability testing, in a realistic way, so that the tests are true to the production environment. So, and for that purpose, we are going to use a few tools. Who here knows nothing about Gerrit? Oh, okay, right, that's a lot. Who has never heard of Jenkins? Oh, just a couple of people. It's a continuous integration tool. that you basically, it's a software that runs, you tell it to do stuff. And that stuff could be whatever you define, and it does that through triggers. And a trigger could be a click of a mouse button, or maybe a certain time of the day, or a commit to a repository. OpenStack is going to be the cloud service, the platform on which we build those servers. Puppet, who has never heard of Puppet? Okay, it's a configuration management tool, which makes sure that the machine, the server, is always in the state that you define it to be in. So if you say, I need this package to be installed, it'll install it if it's not. And if it is, it won't do anything. And of course, we're going to use Python and write some scripts with that to glue this all together. It's not all Python. Gerrit is written in Java. So is Jenkins. OpenStack, the parts that we care about are Python. Puppet is Ruby, and Odoo is Python. Actually, like I said, it's actually XML, JavaScript, and Python. Right, so code review with Gerrit just means that you can't just push changes to the master branch. When you attempt to do so, someone else needs to put the thumbs up first, say that looks good, I'll let that through. So you're gathering a score. It could be that you need one person to review your change. It could be that you need two. It could be that a special person gets to give you 2 points. But there's a human factor. We want to bring in Jenkins and say, right, when you make a change, not only will a person review this, but we're going to build that whole software and then tell you how that went. Jenkins will tell Gerrit how that went, and then give you a +1 or not. So the usual workflow is that your peer will review first, give you the thumbs up, and then Jenkins goes and verifies that nothing breaks. So takes your changes and builds them as if they were real, and then runs the tests, whatever you defined as being your tests, and gives you back your score. But I actually like it the other way around, because I don't want to review broken code. So whenever you commit your change, Jenkins is going to go and build the machine first. And if it's broken, no one will care, and only you will be notified. So in a nutshell, for your changes, or for changes to become effective, Jenkins needs to say yes, your peer needs to say yes, Scotland needs to say yes. Back to the servers, right. So it's not just source code. It's not just some Python scripts we're touching there on the Odoo application server. We want to build the whole thing, and that's where OpenStack comes in. So I'm so lucky to have not only lots of knowledgeable colleagues, but also a cloud service at Catalyst. So I just went to them and said, could I please get an account and get me some servers? And there I was. But there are providers of cloud services, and you pay usually your resources per hour. And it's open source, and you can talk to it in Python. It's mostly written in Python. So the way that works is, of course, only the relevant parts here. You import your Neutron client. Neutron is the name of the tool that lets you do this. Define some parameters, such as what packages you want installed. Or down there, we do something for the DNS and just some, what's the fully qualified domain name, these kind of things. Where do you want to get your packages from? And with another command, you create a new server in the cloud. Now, that'll work through an SSH key, your authentication, and you define what base image you want to start off with, you want to use for the installation. And the network part, that's where the first gotcha is really. We want to set this up so that all those little servers that get spun up and thrown away are all in this same subnet, which is controlled by our build server. Our Jenkins build server will actually not build. It will say, OpenStack, give me some servers. Okay, now you servers, you go and build yourself. And of course, routing access to those servers and vice versa. When they build themselves, they need to go to Gerrit and grab the source code to do so. So they also need to get into the other direction. And a nice little thing that we've implemented was the DNS. So that when you create a new server, there's a nice name for it. And not just that, because we're building an app server and a database server, we use a naming convention and they know who to talk to. So the way that the build works in the steps, because one difficulty was always to figure out which software will actually do which task. So we start off with a base image, latest Ubuntu LTS, let's say, and initialize it so that we can have a server set up that we can talk to and get into. Then we'll use our Python script. Fabric is a little Python library to run SSH sessions. So now we're on that new server. We're grabbing us the latest build instructions from the repo. And then we run the Puppet configuration once. And then this next step I call run my script. This could be anything really. On the test machine, it'll probably be running the test or finishing the installation of some custom modules maybe. And Puppet can be used to configure the machine. So Puppet could really be used for anything. Even in Cloud Init, we could install more than just Puppet. We could install all packages there. So it was really a matter of defining who's responsible for what. And in Cloud Init, we really only install Puppet. All the normal packages, the system packages get installed by Puppet. The Puppet master is sitting on our build server. So this is a little server, a transient server in the cloud. And it it gets configured by Puppet, after which we run our own stuff. A gotcha there is to wait for asynchronous tasks to finish. So usually an asynchronous task is a really nice little thing, fire and forget. Tell me when you're finished, but it's really not that easy for some things. When we create the new server, OpenStack will come back and say, yes, here's your server, but Cloud Init is still installing stuff. So we have to wait for SSH to be ready. We have to wait for Puppet to be ready before we go SSH in and actually run Puppet. And the tricky bit there was to find out when something's ready. It's like spaghetti, they're ready when they're ready. So when is SSH ready? When you can make a connection. When is Puppet ready? I fell into a little trap there. I just checked whether Puppet was installed. So with dpkg, I just looked, is Puppet installed? Sure, okay, let's go. And Puppet was installed, but it wasn't ready. It was still handshaking with the Puppet master getting a certificate. So another little gotcha. What's the time up to? 3. Okay. So this is the big picture. I hope it's visible. Where's those little images I had? Okay, they're gone. Well, on the top, there's Gerrit. Gerrit sits on a separate server, actually. I didn't want to reinvent the wheel, so we used what we had, and there was already a Gerrit server. In the top left corner, that's actually GitHub, because that's where Odoo development's happening. And we have a fake user on the build server, the CI server, it's in the bottom left corner, who regularly picks up the changes from GitHub and then commits them to Gerrit. Because for us, GitHub is just another developer. It's just a very fast one. But those changes may break our software, so they need to go through Gerrit, and Jenkins needs to tell us that it's okay. Right? So once a developer makes a change, it triggers the build, and the new servers, app and database, go and grab their instructions, build themselves up, run the tests. Jenkins gets told the test result, so this is all logged, and then gives the score to Gerrit afterwards. We can also, rather than throwing that server away afterwards, we can keep it, and that's where the DNS comes in. So this actually works. And if you look, I've just put the URL at the top again to make it more readable. So I had two parameters there. One is master and one is latest, a stack and a suffix. And this is the app server, and it's running in the subdomain. And right after the job was finished, I could point my browser to that server. You can imagine for user acceptance testing to always use the same URL, and your end user can bookmark it and just look at the latest build again and again. Improvements. It doesn't always go your way. When you follow instructions on how to build an Odoo server or Odoo servers with database server from wiki instructions or a blog or so, and this is true for other software as well, you'll often find yourself a month or two later, or maybe an hour or two later, regretting certain steps that you took, and you'd like to go back in time and do something a bit differently. That's the nice thing here, is that this is a completely automated process, and every part we can make changes. So when the next version of the next Ubuntu LTS version comes out, we can swap out the base image, build the whole thing on a new version, see how that goes, if it breaks. If we need to add another package or change the packages that need to be installed on the server, the build instructions are also in our repository, and you can even trigger new builds when build instructions change. So you change Puppet manifests, and you say, I need these couple more, and as soon as you commit that to Gerrit, boom, the new build has your new packages. Questions? Do you have questions about this?
How long does it take?
Ah, perfect. Yeah, I can repeat the question if that's faster. Oh, yes, yes. That would be my question too. How long? Yeah.
They just won their gym session today. How long does it take from the start command of building till it's up and running?
Yes. Now, that would be my first impression. Isn't this maybe overkill? How long does this take? All day or what? So don't forget, you would be running your tests anyway. So the real question is, how much more time does this take? How much time does it take to build that server to the moment where we run our tests that we would have run anyway? And the answer in this case is 9 minutes.
So it's 9 minutes more or 9 minutes?
9 minutes more. The test suite for Odoo, remember the number of lines of code? Takes about half an hour by itself. So there you go, 30 minutes plus. Again, it depends on the cocktail of modules, because we don't use all of them. So only those will be tested that are actually installed. But for us, that's half an hour, and the server itself, 9 minutes. Then, of course, other tests that you might want to schedule at night could run longer. Load tests or performance testing. It's up to you. But the base cost of doing it, the full Monty, is 9 minutes. And I think that's time well spent. Any more questions? All right.
I'll take another one. I'll ask. Okay, so roughly how many builds do you have in a day, just for the sake of understand how busy is the system?
Oh, well, I've just been finishing this process. So at the moment, I'm the only developer. And so I'm working on the process itself still, so I'm actually not committing to the Odoo modules. So you can run several in parallel. Like I said, the Jenkins build server is really just a conductor Nothing gets built there, so that scales really well because we can have multiple servers in the cloud building themselves. It's cheap and quick. So, yeah, I would expect to be able to build as many and as often as we need. I don't think, let's say worst case scenario, you say 1 hour, you can build full complete builds, 8 per workday, and that will be enough for our scenario.
If you're doing them in parallel, isn't that a bit of a problem if one that starts actually fails and subsequently you've started another one in parallel?
Yeah, now there's a logic in Gerrit that things get pulled back, changes get pulled back and the thing that gets rerun without, because you don't want to punish someone else's changes just because you broke it. When I say in parallel, these could be multiple branches for multiple projects. Within the exact same build, you do want a queue where you only do one at a time, one after the other. Yeah. There was one.
Did you experiment with masterless Puppet for the ephemeral builds? So there's no Puppet master?
No. And in regards to Puppet, I have to say I wouldn't have chosen Puppet myself if I could start from scratch and with a wish list for Christmas, but I looked around the company, and Puppet is what the sysadmins use and what they're proficient in, and so Puppet it was. And yeah, we have a Puppet master in Catalyst, but this Puppet master here that's sitting on the build server is its own just for this subnet, for the little ones. That's it. Well, thank you very much.
Thank you, Danny. And kind of just, if you want to know more about continuous integration tests in general, and especially also pertaining to OpenStack, there are actually a couple of really nice LCA talks from last year and the year before. I think they ran during the mini-comps. And so there you also see more about how OpenStack uses continuous integration, Gerrit, and so on. I really can highly recommend those. Now we've got about 10 minutes.